Here we have a problem from the AMC 12 math competition in the year 2007, and it asks us to let a, b, c, d, and e be distinct integers, such that when we multiply 6 minus a times 6 minus b times 6 minus c times 6 minus d times 6 minus e, we get 45, and it asks us to find the sum of all of these distinct integers. Okay, let's go ahead and jump into this. So the first thing I want to point out is that none of these integers can be 6. And the reason for that is because if one of these integers was 6, then this whole thing would collapse to 0, and that's not what we want. The second thing is I'm going to go ahead and break this 45 apart into its prime factorization. So we have 3, 3, and 5 here. And so if we're only dealing with integers with a, b, c, d, and e, which this question clearly states, we're only going to have 3s, 5s, and 1s, and then their negative components as well. And we know that we're going to have 2 copies of 3, 1 copy of 5, and then some copy of 1s, which in this case would just be 5 minus these 3. So we're going to have 2 copies of 1s. So let's go ahead and test that out. So if we want 2 copies of 3, then we'll have 6 minus 3, so we'll go ahead and let a equal 3. And then we want the other copy of 3, but this one will be negative, so we'll have 6 minus 9, so we'll let b be equal to 9. Then we'll go ahead and get our 2 copies of 1, so we'll have 6 minus 5, so we'll have c equal 5, and then we'll have 6 minus 7, and that will be d equal to 7. And now we see that this gives us a positive number, this gives us a negative number, this gives us a positive number, and this gives us a negative number. So if our goal is to get positive 45, we need this last number to be positive 5. We'll have 6 minus 1, which gives us e equals 1, but that means that we'll have 5 in that last slot, and this number is positive. If we go ahead and simplify this out, we have 3 times minus 3 times 1 times minus 1 times positive 5. This will be minus 9, this will be minus 1, and that'll be 5. So this whole thing is equal to 45. We know that this is true, so we can go ahead and add all these numbers together. So we have 3 plus 9 plus 5 plus 7 plus 1. And adding all of these up, we get these sum to 25. So this will be our final answer, but we haven't really proven that 25 is the definitive answer here. We've only kind of guessed using these numbers up here. So what I'm going to do next is I'm going to erase this, and then we'll prove that 25 is the only sum that can occur here. So as stated before, we know that 45 breaks down into 3 squared times 5. So we're going to have some combination of plus minus 3 times plus minus 3 times plus minus 1 times plus minus 1 times plus minus 5. And we used plus 3 minus 3 plus 1 minus 1 and positive 5. But let's look at what if we have a negative 5 here, because that's the only change that will really make a difference, because we know that all of these numbers are distinct. They cannot equal each other. Well, if we have a minus 5 in here instead, we can leave this as plus 1, and we can leave this as minus 1, and then we can leave this one as minus 3. And so now we have a minus number, because we have minus, minus, plus, minus. So this whole thing right now multiplies out to a negative number, so we would need another negative number here. But that contradicts what we were given in the original problem, that we have to have distinct integers when we give this to be a minus 5. So we know that because we have distinct integers, this has to be positive 5 in this last slot. And because of that, this has to be the layout for our equation. And as before, we showed that with this layout, we have that a plus b plus c plus d plus e is equal to 25. I think that's enough for now.